Kritika. Thank you for coming, agreeing to come on my show. And what are you going to show me today? I believe that you work with children.
Yes,
Tell a little bit about your work.
so I run a company called STEM Metaverse, and the idea has always been to actually make things practically visible to students so that they can actually experience what's happening.
So you're talking about science experiments.
Science experiments
You're
and
bringing science lessons to life.
also maths, also a couple of other things. We learn a lot of concepts in school, and what happens very often is that you see them only as numbers or as statements. You don't really see them as things that actually exist.
Oh, so what you are saying is, basically that the way it's taught in schools is imagine this is a test tube, and imagine I'm putting something in this, and then imagine this is a pulley, and I put a weight here. So everything you have to work out and you have to think in your head.
Exactly. So it took me a while to understand that pulley is basically changing the course of direction pulley. But when that realization struck, I felt this is just so bad. It should have struck at least 3-4 years earlier, in grade 3 or 4 when we learned simple
When we learn about
So then I think it's been a age old, and this is after coming from a family where everything has been experiential. Despite that, I found that there is so much that cannot be made available at home, and I think as facilitators in schools, maybe we're in a better position to do it for our children. So that was the idea.
Yes. So at least now everyone is realizing the importance of experiments and hands-on experiments, hands-on activities,
Right.
where you're actually learning from doing.
Yeah.
Right. But even then, there is a lot more that can be done, which I think you are doing. You are introducing.
I think there's a lot more
you
than
are,
even I can
yes,
do.
you are as an innovator. You are having this innovative practices. So what do you have to show us today? Tell me.
So, these are, I think all of us have done lens experiments, right, at some point. And we drew all those ray diagrams, got them wrong many a times.
I did it in 11th and 12th. We did these experiments when we would have these huge optical benches, and on that we would move. There would be those fixed things and the lens, and then there's a pin, and then trying to remove the parallax and trying to prove something.
Ma'am, we never did it.
You didn't do it,
We didn't do it. We never got lenses in our hands. And forget about having, even though we had labs in schools, but we never did this. And this was taught in around 8th standard around my time. But those lens diagrams were only diagrams. They never translated into anything more than that. When we were told about the scattering of light, we had to imagine a room with a door half open and light coming in and then being able to see it. We had seen those things then, but in the class, it was never visible. So the idea has been, how do you make it visible for children so that they can take this as a visual. A lot of us are visual learners. Absolutely, take that visually. I think with science, a lot has still been done. With math and even language, I think it's all 2D. There is nothing.
It reminds me, when you're going to talk about optics and light, it reminds me of an incident. Not an incident, it was something that was ongoing. So when we were in college, we used to do some dark room experiments.
Yeah.
And there was a very small room which had been made dark all around. So there were heavy curtains and black paper fixed on the windows. But what happens is that with time, there were holes in the curtain and in the black paper that was fixed on the window panes. And this room was just overlooking the main entry gate as well as the road. Okay. So now what happened is that these small little holes started acting like like the holes that you have in a pinhole camera. So the entire room, actually we were sitting inside the camera, and whatever you could see cars and people walking all inverted all over the walls.
That's amazing.
That is something I've never could imagine and never seen elsewhere.
No,
it just happened incidentally because there were holes in the curtains.
Imagine what an exceptional learning.
Absolutely, and it can be done so easily anywhere.
Yes.
You can
But
just do
we
it
don't make
anywhere.
them do pinhole cameras now. And that's the sad part. I mean, I asked so many students, so we're going to do it tomorrow. But basically, pinhole cameras, they're so simple to make, but
So
people don't
simple
get
to
them
make.
to make.
They're so simple to make. Yes.
Yeah.
So tell me about this.
Yeah, so we created.
So you have a
the
lot of
lights
stock.
off. Yes, so we've got a group battery inside.
Yes.
Very simple. Let's start on this a little bit. And oh yeah, the holes are on this side.
that you have fixed the lens here. It's a
Yes.
convex lens, I
It's
assume.
a convex lens, and it's a, I think this is a 10 FL lens, 10, the focal length is 10. So now if you look at it,
10
see how it's bending,
centimeters.
10 centimeters. So now see how it's bending, the light is bending, and because of the smoke, the light's scattering. Children learn two things from here. One is that light travels in straight lines, and also that, how do lenses actually work? Because if I put a glass slab in between, the light won't bend.
Oh, okay.
So when you do that, it sort of shows up. So here, if you look at it here, the light's not bending here too much. Here, the
Oh,
light's
so
straight.
it's traveling in
Now
a
it's
straight
straight.
line.
It's traveling in a straight line.
Straight line, that's
But
right.
the moment I put it on a curved surface, suddenly
Right.
you see that it's coming somewhere here.
Yeah,
It's
so
bending.
it's bending.
And then around the center, it's
Right.
the same thing. It's bending, but it's not bending too much. But when I go down, it's
Ah.
all inverted. So the image would be inverted because what's below is now showing up.
Right.
So for children, this is a realization, because when we showed them the same thing that you were talking about on the window, that inverted window with children and their hands hanging from top, they were amused. But when we said that, okay, now see that this ray at the bottom is coming on top here, and then this ray from the top is coming at the bottom, they were amazed. They said, wow, this makes sense. So this circular object, then when we told them that in your eye the images formed are inverted and your brain is erecting them, they were totally baffled and they were just completely amazed. And when,
Yeah, that's
it's like a lot of things, sort of set in place for them. So it's interesting because then that realization happens.
That's right.
And connecting this with some children have spectacles, I have spectacles. So understanding how do spectacles work, how does a piece of glass, change your vision. So it's amazing. So when you talk about focus, focal length, a lot of things come into perspective. You can take a shot of this maybe, that there is a scale over here, and when I put it around here, it shows up. This would have been more convenient. Yeah. Now see, can you see it converging?
Yes.
The idea for this was that, okay, if we are actually talking about focus, focal lengths, and how, how it impacts our lives, children actually get to see how it acts, and they also get to see how images are formed within our own eyes. Also, how lenses impact us.
Right.
So then a lot of children, they picked up their glasses and they actually touched their lenses to see if there was a difference. And that's where I think, a lot of realizations happen.
Yes, and then you can make a distinction between what's a convex lens in your glasses that you're wearing,
Right.
spectacles, whether it's convex or concave.
Right.
And how is it that your eye works and how the
And
glass
yes,
it's
exactly.
a correction lens actually.
Right. So, and why is it that everybody's lenses are different?
Different eyes, different shapes.
Right. So, so while as a concept I think all of us understand it, when you actually just see it, it just stays there with you visually.
That's right.
So which
Thank
is
you.
rare.
Thanks.